we learned about initial value problems on page 75 in your note packet. And basically what initial value problems are is we have to find a function f of x given its derivative f prime of x and the value of the function f of x at some value of x. So given some value of x, we know the value of the function at that value of x. We also know the derivative of f of x, and using that information, we got to figure out what f of x is equal to. So, in the first example on page 75 of your note packet, you're given the derivative of f of x, f prime of x is equal to 3x plus 2, that's the derivative, and the value of the function at x equals 1 is equal to 5. So that's the two pieces of information you're given. So the first thing you want to do, step 1, is find f of x within a constant c by anti-differentiating f prime of x, right? F prime of x is the derivative of f of x. The antiderivative of f prime of x is f of x. So f prime of x is 3x plus 2, so the antiderivative of f prime of x is equal to the antiderivative 3x plus 2. And the antiderivative of 3x is 3 halves x squared. The antiderivative of 2 is 2x, and then we add the unknown constant c. So we know the original function f of x to within a constant is equal to 3 halves x squared plus 2x plus c. Well, using that the value of the function x equals 1 is equal to 5, we can determine what c is. To determine what c is, we evaluate the function x equals 1. And to evaluate the function x equals 1, we just put in 1 in for x. So we have in step 2 over here, f of 1 is equal to 3 halves times 1 squared plus 2 times 1 plus c. And now we know that f of 1, right, is equal to 5. So I replace f of 1 with 5. And then this simplifies to 3 halves plus 2 plus c. And then when I solve for c, I get c is equal to 3 halves. So now I know the constant, right, over here is equal to 3 halves. And so now step 3 is put in 3 halves in for c over here. And I have the function f of x has to equal 3 halves x squared plus 2x plus 3 halves. So this function f of x has this derivative, 3x plus 2, and when I evaluated x equals 1, the value of the function is 5. All right, class, in this next example, in example 2, at the bottom of page 75 of your note packet, we're given f prime of x is equal to 2x cubed minus 5x plus 3, and the value of the function f at x equals 0 is equal to 7. And so we go through the same 3 steps. Step 1 is to find f of x to within the constant c. F of x is equal to antiderivative of f prime of x. F prime of x is equal to 2x cubed minus 5x plus 3. And so the antiderivative of 2x cubed minus 5x plus 3, right, anti-differentiating term by term. Antiderivative of 2x cubed is 1/2 x to the 4th. Antiderivative of minus 5x is minus 5 halves x squared. Antiderivative of constant 3 is 3x. And then we add the unknown constant c. Now, to determine the unknown constant c, we evaluate the function f of x at x equals 0, and we know f of 0 is equal to 7. So when I put in 0 in for x up here, this first term, 1/2, is going to be 1/2 times 0 to the 4th, that's 0. 5 halves times 0 squared is 0. 3 times 0 is 0. And so I'm just going to have f of 0 is equal to plus c. Well, f of the 0, the function at x equals 0 is equal to 7. So I have 7 is equal to c, or c is equal to 7. And now to find f of x, the exact function, f of x. I put in 7 in for c here, and we have the function f of x is equal to 1/2 times x to the 4th minus 5/2 x squared plus 3x plus 7. So this is the function f of x that has this derivative up here, and at x equals 0, it's equal to 7.